For the first time in more than half a century, we've done it. Humanity has gone back to deep space, looping around our closest celestial neighbor, the Moon. This is the story of Artemis II, an incredible 10-day voyage that really pushed the boundaries of exploration and set the stage for our permanent return. So let's dive into how it all went down.
I mean, just look at that view. It's pretty easy to see why we keep wanting to go back, right? And the name for this whole program, Artemis, is just perfect. If you remember your Greek mythology, Artemis was Apollo's twin sister and the goddess of the moon. As NASA puts it, Artemis now personifies our path to the moon and beyond. Kind of poetic. So, you might be asking, after 50 years, why now? Why go back? Well, this is not just about redoing what we did in the past. The Artemis program is aiming for something so much bigger than just planting another flag and leaving a few footprints. It's all about building a real, lasting future for us in deep space. And that's the grand vision, right here. It's crystal clear. The moon is not the final stop. No, it's more like a crucial stepping stone. The idea is that by learning how to live and work on the moon sustainably, we can figure out all the tech and get the experience we're going to need for that next giant leap, putting human boots on Mars. Okay, so this chart shows you exactly where Artemis II fits into the whole master plan. You had the uncrewed Artemis I flight first to test the rocket and capsule. Artemis II, the one we're talking about, was the all-important crewed test flight. And because it was such a success, it gives the green light for the big one, Artemis III. That's the mission that's finally going to land astronauts back on the lunar surface. And you can't talk about this mission without talking about the 4 incredible people who actually made the journey. This was an international crew, which is pretty cool. 3 NASA astronauts and 1 from the Canadian Space Agency. Just think about it. These are the very first human beings to travel into deep space since the Apollo missions wrapped up all those years ago. All right, let's get into the journey itself. This wasn't just a quick trip. This was a super carefully planned 10-day flight that was designed to push the Orion spacecraft and its crew to their absolute limits. So the mission used this incredibly smart flight path called a free return trajectory. Think of it like a cosmic slingshot. You aim the spacecraft just right, and the moon's gravity does all the work. It literally grabs the capsule, whips it around the far side, and then flings it right back towards Earth. The big deal here is safety. It's a built-in backup plan. Even if their main engine totally failed out there, they had a guaranteed ride home. And this map gives you a fantastic bird's-eye view of that whole path. You can literally trace the entire 10-day trip. You see the launch, then those first few orbits around Earth to check all the systems. Then there's that big engine burn that sends them off to the moon, the 4-day coast out there, the flyby itself, and then the 4-day trip back home, ending with a splashdown. Now, getting that trajectory absolutely perfect took some mind-blowing precision. While that free return path was the backup, a whole series of critical engine burns guided the Orion capsule, which, by the way, the crew named Integrity. You can see a few of the key burns here, but the real showstopper was the translunar injection, or TLI. That was a burn that lasted over 5 minutes, and it was the moment they truly broke free from Earth's orbit and were officially on their way to the moon. And get this. At the farthest point in their journey, the crew of Artemis II traveled 4,600 miles beyond the far side of the moon. Just let that sink in for a minute. That absolutely shattered the old record. They became the human beings who have traveled farthest from our home planet. Can you even imagine looking back from that distance and seeing our entire world as just a tiny blue dot? So after this incredible, successful trip out to the moon and back, you'd think the hard part was over. Nope. The single most dangerous, most critical phase of the entire mission was still ahead of them. That fiery, high-stakes re-entry through Earth's atmosphere. I want you to try and wrap your head around this speed. The Orion capsule hit the top of the atmosphere at a blistering 24,000 miles per hour. That is so fast, you could get from LA to New York in about 6 minutes. All of that insane speed, that kinetic energy, has to go somewhere. And it all gets converted into raw, intense heat. And that means the heat shields at the bottom of the capsule had to endure temperatures reaching an unbelievable 5,000 degrees Fahrenheit. To give you some perspective, that is about half as hot as the surface of the sun. This was, without a doubt, the single most extreme test of the entire mission. And you know, this wasn't just a what-if scenario. There was a very real, very specific reason for everyone back at Mission Control to be nervous. Because of something that happened on the previous flight. The performance of this one component, the heat shield, was the single biggest question mark hanging over the entire mission. And here's exactly why. When the uncrewed Artemis I capsule came back, engineers found something a little bit worrying. As this quote lays out, the heat shield had worn away in unexpected ways that their computer models just didn't predict. I mean, it worked, but the damage was unexpected. And that discovery kicked off months and months of intense analysis to make absolutely sure it was safe enough to put a human crew behind it. So how on earth did they handle all that incredible heat and energy? Well, they used a really brilliant maneuver called a skip re-entry. It's just like it sounds. Orion basically dipped into the upper atmosphere to bleed off a massive amount of speed, and then it literally bounced or skipped back out into space for a bit before making its final plunge. It's the exact same physics as skipping a stone across a lake, and it was the key to making the whole landing survivable. So after 10 days in deep space in that nail-biter of a re-entry, the final chapter of the mission was a gentle splashdown in the Pacific Ocean. It was a successful end that really kicked off a brand new era of human exploration. And there it was, on April 10th, 2026, the whole world was watching as Integrity's 3 huge main parachutes blossomed in the sky, lowering the crew safely down into the waters of the Pacific. Their 10-day, million-mile journey was, without question, a massive success. I mean, just look at this list of what they accomplished on this one flight. It's staggering. It was the first crewed mission to the moon in a generation. It proved all of Orion's critical life support and navigation systems worked perfectly. It set that new human distance record, and maybe most importantly, it proved that the heat shield was ready for human missions. That clears the path for the next giant leap, Artemis III, and finally landing back on the moon. So the real takeaway here is that this successful splashdown wasn't an ending. It was a beginning. It was the final piece of proof that the hardware, the people, and the plan are all ready to go. We can move beyond these short test flights and start building a real, long-term human presence on the moon. And this image right here, this is what it's all about. This is the ultimate goal. In Artemis Base Camp, we're talking about establishing a permanent human foothold on another world, where we can live and work and prepare for that next great journey out into our solar system.
The 4 astronauts of Artemis II came home safe and sound, but what they really accomplished was paving the way for humanity to leave home for good. They proved we have the technology and the will to become a multi-planetary species. The question isn't if we'll go anymore. The question now is, where do we go next?